Good morning. This lesson is for my Honors Integrated 1 class and my Integrated 1 class. But before I get started, I want to say I hope that everyone's doing all right out there. I'm not sure how I'm going to title this. I'll title it how I title it in the title. But what I am sure of are 3 goals for the day. Our first goal is going to be to investigate a condition needed for a parallelogram to be a rectangle. Our second goal is going to be to investigate the conditions needed for a parallelogram to be a rhombus. And our third goal is going to be to investigate the conditions needed for a parallelogram to be a square. So, one of the things that students struggle with is knowing what they're trying to accomplish with their argument. And so I thought that instead of me just jumping right into this lesson and arguing it, I thought it would be a good opportunity to ask you guys the open-ended question. What would you have to argue to show that your parallelogram is a rectangle? What do we have to prove about our parallelogram? What property must our parallelogram have in order to be a rectangle? And once you understand what the parallelogram has to do to be a rectangle, you can start to figure out how you're going to argue that property. So why don't you hit pause, see if you can come up with an idea of what you're trying to argue. And if you think you have what you're trying to argue too, why don't you try to see how you could create the argument and then watch and see if we agree. If we don't agree, well, at least you tried. And if we do agree, wonderful. That is wonderful. And then, think about the next couple of goals. Maybe you don't really need to pay attention to this video and you can figure it out on your own. So why don't you hit pause, answer this question, what would you have to argue to show your parallelogram is a rectangle? Hit pause, try to figure that out, and I'll be back. I'm back, so hopefully you took some time to figure out what you would have to argue to show your parallelogram is a rectangle. And what you would have to argue is you would have to argue that it has all right angles. All the angles are right angles. You would have to argue, you have to show so that's what we're going to argue towards. So there's a couple different ways to argue this. I'm going to argue it in one style. Let's try and see if we can figure out what the other one is, if you want. But we want to show that a parallelogram with congruent diagonals is a rectangle. We will use our congruent triangle style, and this is what we start with. So this is what congruent diagonals look like, and they bisect each other because it's a parallelogram, right? And because ABCD is a parallelogram, we inherit all of the properties of a parallelogram. We will use the congruent opposite sides property. So now we have the following. So I added the congruent opposite side marks to my parallelogram, and notice that we have 2 sets of congruent triangles, or 2 pairs of 2 congruent triangles. First, we have triangle AEB is congruent to triangle CED. And this is by side, side, side. Secondly, we have triangle AED is congruent to triangle BEC, again by side, side, side. Now, remember, congruent triangles have congruent corresponding parts, but that's not all that we have going on here. We actually have a little bit more. All the little triangles in here are isosceles. And since all the triangles are isosceles, we inherit the fact that the base angles must be congruent. So all triangles are isosceles. All congruent triangles are isosceles. So if we have isosceles triangle, that means we get a triangle that has congruent base angles. And this is very important because if I was to, let's see if I can still fit on this. If I was to redraw this again, and I hope that I'm on the screen, and we know that everybody's congruent, right? But if I was to draw this and label these congruences, where did I hide my red marker for myself? Right here. If I was to label these congruences, I would know that this angle is congruent to that angle, as well as these two angles. And then these pairs of angles would also be congruent. Right? Now, the reason why this is important is now that I know that I have these congruences, I can now get to the goal of this argument, which is to show that I have 4 right angles. So, let me hopefully make this as simple as possible. I'll call these little angles x degrees in measurement. I'll call these angles y degrees in measurement. Okay? And I have a 4-sided shape. So we know that the 4 angles of a 4-sided shape add to 360. The 4 angles of any quadrilateral add to 360. You know what? I'm going to make sure that I'm on the screen here. I would hate to have to record this again. Okay, I've got a little bit more room than I thought. All right, so the 4 angles of any quadrilateral add to 360. Okay, well, that means that y plus x, x plus y plus x, and x plus y must add to 360, right? So I have 4 x's, and I have 4 y's, and I know that together they have to add up to 360 degrees. Now, what I can do is I can divide away the 4, or divide everybody by 4. And what this does is this shows that x degrees plus y degrees adds up to 90 degrees. So what this means is that's a right angle, and that's a right angle, and this is a right angle, and finally that's a right angle. So this shows that our parallelogram is a rectangle, right? So I argued that I have 4 right angles. This shows we have a rectangle. So if we start out with congruent diagonals, and it's a parallelogram, then our parallelogram must be a rectangle. So let me clean this up, come back, talk about our second goal, investigating the conditions needed for a parallelogram. So let me clean this up, and I'll be back. I'm back, so let's go ahead and start our second goal, and we'll start off with the same question that we had for our first goal. What would you have to argue to show that your parallelogram is a rhombus? So why don't you hit pause, see if you can figure out what you have to argue towards in order to accomplish the argument that your parallelogram is a rhombus. So hit pause, give it a shot, and I'll be back. I'm back, so let's go ahead and continue with our second goal, and we've left with the question, what would you have to argue to show that your parallelogram is a rhombus? Well, what you would have to argue is it has all congruent sides. All sides are congruent. That's what you would have to argue. All sides are congruent. That's what it means to be a rhombus. Okay, so that's what we're going to try and achieve. Now, again, notice this is conditions plural, so there's going to be a couple initial conditions. So we'll start with one. Let's start with a parallelogram that has perpendicular diagonals. So we have something that looks like this. Because RSTU is a parallelogram, it inherits all the properties of a parallelogram. For this argument, we'll use the fact that the diagonals bisect each other to achieve our goal. So here I've drawn it again. They're not the same size. It doesn't bother me. Hopefully it doesn't bother you. But let's use that fact. So I know that from U to V will be the same as S to V. That's a diagonal that's bisected. And I know that from T to V will be the same as R to V. Now, we actually have 4 congruent triangles here. There's 4 congruent triangles. So at any time, if you think you know how this argument's going to go, why don't you hit pause and see if you can argue it and see if we agree. You're not going to get better at this unless you try. All right, so let's see here. What did I just say? We have 4 congruent triangles. Right? And they're congruent because of side angle side. 1, right angle, 2. 1, right angle, 2. 1, right angle, 2. 1, right angle, 2. Right? So I could say that triangle, I'll write it like, go from the side of the 1 to the right angle to the side of the 2. So UVT, so triangle UVT is congruent to triangle, let's see, 1, right, 2. 1, right, 2. So SVT, and that's congruent to triangle SVR, and that's congruent to triangle UVR. Now, because we have congruent triangles, that means the corresponding parts are congruent, right? And don't forget what we're trying to argue towards. All right? Don't forget what we're trying to argue towards. We're trying to argue that all sides are congruent. So I need to show that UT is the same as ST and as SR and RU. So let's see here. So TU, the last and the first. So I know that TU is congruent to TS. Okay, the last and the first. And that's congruent to RS. And that's congruent to RU. So I've shown that a parallelogram that starts with perpendicular diagonals must be a rhombus. This shows that we must have a rhombus. So there's one more initial condition that we can start with that will give us a rhombus that a parallelogram has. So let me clean all this up and I'll be back. I'm back. So let's go ahead and continue with our second goal, and that's investigating conditions needed for a parallelogram to be a rhombus. We want to show a parallelogram that has a diagonal that bisects a pair of opposite angles is a rhombus. It's kind of a tongue twister. And a rhombus is a quadrilateral with all sides congruent. Remember, that's what we're trying to argue towards. And so this initial condition of a diagonal that bisects opposite angles, hopefully we can argue that it is what we need to have a rhombus. All right, so this is what we start with. We have a diagonal that bisects opposite angles. So angle KJM got cut in half, and angle MLK got cut in half. That's what happened. Okay. So because JKLM is a parallelogram, it inherits all the properties of the parallelogram. For this argument, we will use a property that opposite angles are congruent. So the angles that are bisected are congruent. So we get 4 congruent angles, and now we have this. So angle KJM and angle when I just said MLK, KLM, they were bisected, but in fact, because it's a parallelogram, these initial angles are the same, and if we cut identical angles in half, we get 4 congruent angles. Now, we can continue with our triangle argument. JL is part of both triangles, so JL is congruent to JL. So, we get congruent triangles by angle, side angle. So, triangle, we'll go MLJ is congruent to triangle KJL. Not only that, but both triangles have the following property. And both triangles have congruent base angles. So, what that means is if I have this condition, that means that I have that condition. So, in fact, our congruent triangles are actually isosceles triangles. And so what that forces is side JK, no seriously, is congruent to side KL. And since we have congruent triangles, that means that LM is congruent to MJ. And this shows, or this completes our argument that we have a rhombus. All right, so I can actually now check off, we should check off the first goal, I can check off the second goal, and I'm going to come back and talk about the third goal and see if we can wrap up this lesson. So again, hopefully you understand what I'm trying to argue towards, and I'm still using the triangle argument, but now I got to use a little bit more here, right? So the congruent triangles got us to a certain point, but then we had to recognize we had congruent base angles, which led us to isosceles triangles. So you're really seeing a lot of properties being used on these lessons, and I think it's good for you guys to see. So let me clean all this up, come back with the third goal, and I'll be back. I'm back, so let's go ahead and start our third goal here, and I'm just going to start off with a question like I have with the prior two goals, and it is, what do we have to show about a parallelogram so that we can conclude it is a square? So why don't you see if you can answer that question, and hit pause. I'll be back. I'm back for the last time, I promise. So let's go ahead and jump into our third goal, and it's to investigate the conditions needed for a parallelogram to be a square. Now remember, squares are rectangles and rhombuses, or rhombi. So what do we have to show about a parallelogram so that we can conclude it's a square? Well, we have to show it is a rectangle, which means it has 4 right angles, and it is a rhombus where all sides are congruent. Well, we know how to show a parallelogram is a rectangle. We know how to show a parallelogram is a rhombus. So the parallelogram would need to have congruent diagonals, which would make it a rectangle. It would also need to have perpendicular diagonals, or a diagonal that bisects opposite angles to make it a rhombus as well. So we need congruent diagonals and congruent diagonals that are perpendicular, or we need congruent diagonals where one of the diagonals bisects a pair of opposite angles. That would make it a rectangle and a rhombus, which would make it a square. All right, so that finishes the third goal. Right? It has to do both. Oh. All right, so let's just end this with a summary of the lesson. If I have a parallelogram that has congruent diagonals, it is a rectangle. And from the previous section, we saw that if we have a rectangle, we get congruent diagonals. We showed that a parallelogram that had perpendicular diagonals is a rhombus. And from the previous lesson, we saw that a rhombus must have perpendicular diagonals. And finally, if a parallelogram has a diagonal that bisects the opposite angles, that must be a rhombus. And from the previous section, we saw that a rhombus must have diagonals that bisect opposite angles. Right? And so finally, if I have these two conditions, I have a square. Or if I have these two conditions, I also have a square. Okay? So see if you can draw what that looks like and get a better understanding of what a square is. So I'm going to go ahead and end this lesson here. Again, I hope everyone is doing all right out there. Have a great day, everybody. Bye-bye.